Earth is not a perfect sphere of unbroken stone. It's fractured, cracked, and scarred. Some of those cracks lie silently for millions of years, while others slip suddenly, unleashing earthquakes that devastate cities. In geology, we call these breaks either fractures or faults. At first glance they may look the same, but the difference between a simple fracture and an active fault is the difference between stillness and motion, between safety and disaster. In this documentary, we'll explore the science of faults and fractures, their role in Earth's dynamic crust, and how they shape the landscapes, resources, and hazards of our planet. Let's start with fractures. A fracture is a break in rock where no significant movement has occurred. They form when stress builds in the crust, from cooling, stretching, or pressure release, and the rock simply cracks. You see fractures in road cuts, cliffs, and mountain walls. Some fractures are microscopic while others span kilometers, but they don't offset the rock layers. They are frozen snapshots of stress, not agents of change. Fractures matter. They provide pathways for water, oil, and gas. They control weathering, erosion, and even the shape of valleys. In fact, many aquifers, underground water stores, exist because fractures allow water to flow through otherwise impermeable rock. Now compare that to faults. A fault is a fracture where movement has occurred. It might be millimeters, or it might be hundreds of kilometers, but the key is displacement. Faults are classified by motion. Normal faults, where crust stretches and one block drops, reverse or thrust faults, where crust compresses and one block rides up, and strike-slip faults, where blocks slide past each other horizontally. Every earthquake you've heard of, from San Francisco in 1906 to Japan in 2011, is the result of a fault suddenly slipping. Faults are fractures in motion, and their movement is the heartbeat of plate tectonics. The San Andreas Fault in California is perhaps the most famous strike-slip fault, a boundary between the Pacific and North American plates. It creeps silently most of the time, but occasionally jerks violently, producing earthquakes that reshape cities. The Himalayas are stitched with thrust faults, where India collides with Eurasia. Each slip lifts the world's highest mountains higher still. East Africa's Rift Valley is cut by normal faults, where the continent is slowly tearing apart. Here, entire landscapes sag and split, forming valleys that may one day become a new ocean. Faults are not just geologic curiosities, they are hazards that directly affect billions of people. Earthquakes along faults destroy infrastructure, topple buildings, and alter landscapes. Liquefaction, when shaking turns ground into liquid, is common in fault zones. Landslides often cascade from slopes weakened by faulting. Yet we build cities atop these zones. Mexico City, San Francisco, Istanbul, and Tokyo all live with the risks of faults beneath their foundations. Faults and fractures also bring opportunity. They create traps for oil and gas, where impermeable rock shifts against reservoir layers. They form conduits for mineral-rich fluids, leading to ore deposits of gold, copper, and uranium. They direct groundwater, making springs and aquifers possible in arid lands. Even geothermal power owes much to fault systems, where heat and water rise together. Geologists map faults to understand Earth's history and anticipate hazards. By measuring offset layers, they reconstruct movements over millions of years. GPS now tracks active faults shifting by millimeters each year, but can we predict earthquakes? Not yet. Faults slip unpredictably, and stress release is complex. Instead, we forecast probabilities, where earthquakes are most likely, and how strong they might be. Still, the more we study faults, the more we learn to live with them, designing safer buildings, preparing communities, and understanding risk. Fractures are Earth's silent cracks. Faults are fractures in motion, engines of earthquakes, mountains, and rift valleys. Both are essential to understanding Earth's crust. They shape landscapes, direct water and resources, and remind us that our planet is alive with motion. Next time you see a crack in rock, consider, is it a fracture, frozen in time, or a fault, waiting for its next move? Either way, you are looking at Earth's restless heart.